Everybody, welcome to our Unit 5 review. For our test that's coming up tomorrow, we have our molar mass, dimensional analysis, moles, and percent composition. Those are the four main topics that will be covered. I will tell you, the majority of what will be covered will revolve around these three. There will be a little percent composition and then a lot of dimensional analysis. So we'll cover each one of those briefly right now in our Unit 5 review. So we'll start off with molar mass. Now with molar mass, you need to have your periodic table because you determine the molar masses based on the periodic table. So if it's just one element like calcium, we would look here at our periodic table and we would find calcium, which is right here, number 20, and we would look at the mass number that is found below the Ca, which in this case, if you look at your periodic table as well, you'll see that the mass number of calcium is 40. So therefore, the molar mass of calcium is 40.0 grams per mole. And that's the measurement we always want to use, is grams per mole. So if it's one element, you get it straight from the periodic table. If it's more than one element, like here we have NO3, which is nitrate, you have to add together the molar masses of N and O. But you also need to pay attention to any subscripts. Now this would typically be a subscript, which would be a small 3 down here. And you have to add their molar masses together. So in this situation, we have N, and N's molar mass, do it down here, N's molar mass is nitrogen, and it's 14.0 grams per mole. And then oxygen's molar mass is about 16 grams per mole. But we have 3 oxygens, so we have to do 16 times 3, which will give us 48. Because we have 3 oxygens, so we have to multiply that 16 times 3. Then all you do is you add the two totals together. So you would do 48 plus 14, 48 plus 14, use a calculator to make sure I don't mess it up, and you get a total of 62 grams per mole. 62 grams per mole. For NO3, got that by adding 14 grams per mole for N, which I got from the periodic table, and then oxygens was 16 grams per mole, but I had to multiply that by 3 to get to 48. Now we'll look down here at iron chloride. Again, it's the same process as nitrate. So first we identify our elements and their molar masses. So we have iron. If we look at our periodic table, iron is atomic number 26, and its molar mass is about 56 grams per mole. Then we have chlorine. Chlorine is atomic number 17, and its molar mass is about 35 grams per mole. You're always going to want to round. How many irons do we have? We only have 1, so we don't need to do anything to this 56. But chlorine, we have 3 chlorines. We have to do 35 times 3, which is going to give us 105. Check my work, 35 times 3, 105. Victory for Mr. Wilson once again. 105 grams per mole total for chlorine. So then, how do we finish it off? Well, we have to do 105 plus 56. So 105 plus 56, that's going to give us a total of 161 grams per mole for iron chloride. So again, you're just adding together their molar masses. We'll look at one more here, magnesium hydroxide. We have 3 elements involved. We have magnesium, we have oxygen, and we have hydrogen. So we have Mg, we have O, and we have H down there at the very bottom. All right. Mg, its molar mass is 24 grams per mole. Magnesium. Oxygen is 16 grams per mole. And hydrogen is 1 gram per mole. Now, anytime you have a subscript outside the parentheses, that subscript applies to both elements inside the parentheses. So we have to do O times 2, so we have to do 16 times 2, and we have to multiply hydrogen times 2. So multiply hydrogen times 2. So here we end up with 32 grams per mole total, and here we end up with 2 grams per mole total. So then, just add them all together. 24 plus 32 plus 2, 24 plus 32 plus 2, get a total of 58. Put it up here. Get a total of 58 grams per mole of magnesium hydroxide. And you saw that because I just added together the molar masses of each individual element, and both elements inside the parentheses had to be multiplied by 2. So that is molar mass. You can always go back and watch the molar mass video as well for extra practice. Dimensional analysis. There's two types of dimensional analysis we're going to look at, using time and then using moles, and grams and things like that. So this is a question a lot of you missed on the review quiz yesterday. We start off with 37 days. The first thing you always write down is your given. Every single time. You always need to write down your given. As soon as you have your given written down, you need to make your picket fence. So I have my given, which is 37 days. Now diagonal from that, I need to cancel out days. So I need to put 1 day. You always have to have matching units diagonal from each other. So 1 day. And then above 1 day, it has to be what equals 1 day in chemistry? Well, we have that given to us as well. And so that's 90 minutes. So far, I have canceled out days and am at minutes. Do I want to stop there? No, because we need to finish with hours. It says how long do we have left in this class. It's supposed to be how many hours do we have left in this class. So down here, I want to end up here with 1 hour, right? So how can I cancel out 1 hour with 90 minutes? Well, 1 hour lasts 60 minutes. That will allow me to cancel out minutes, and then 1 hour and 60 minutes equal each other, so that works just fine. Then all I have to do is 37 multiplied by 90, and then I have to divide by the bottom, which is 60. So you do 37 multiplied by 90, and that gives you 3,330. But then you can't forget, you have to divide by the bottom, which is 60 in this case, and you end up with a final answer of 55.5 hours remaining. So that is how long we have left in chemistry, is 55.5 hours. Now, down here we have years in 300 hours. So again, the first thing you have to do is write down your given, which here is 300 hours. Then you build your picket fence, just like that, 300 hours. Coming across. We got to get to years, right? So that can actually be a little bit difficult. Let's go from hours to days. So 24 hours are in 1 day. And I did that because we want to get bigger, because we're going from hours to years, so it has to get bigger, and I needed to cancel out my hours. So hours, they got to match. Hours are canceled out. Now we can actually go right from there from days to years, which is actually not too bad. So we have 365 days. Actually, will be legit, will be accurate. 365.25 days because of leap years in 1 year. So then we have canceled out days, and we've arrived at years, which is what we wanted to arrive at. Then all we do is multiply the top and divide it by the bottom. So on the top, we just have 300. On the bottom, you got to do 24 multiplied by 365.25, which gives you 8,766. So you have to do 300 divided by 8,766. In 300 hours, as you can anticipate, it's a small number of years. It is 0.034 years is our final answer. And we got that because we did 300 divided by 24 times 365.25. So you end up with 0.034 years. So that's how we do dimensional analysis using time. Now dimensional analysis, our first one here is grams to moles, and the next one is moles to grams. Use your pink sheet for these. First thing you always do is write down your given. Here our given is we're looking for how many grams are in 0.82 moles. So we have 0.82 moles. So that's our given, and we know these are just one-step problems, so this actually doesn't have to be too big of a picket fence. So then we have 1 mole right here, and 1 mole, I give you the molar mass right here, is 160 grams per mole. 160 grams. So that allows us to cancel out moles, and then all we have to do is multiply 0.82 times 160. 0.82 multiplied by 160, you end up with 131.2 grams of iron oxide. I just gave you the molar mass there, and that's what we were dealing with, those iron oxide. So 131.2. Should have gotten that set up from your pink sheet. Okay, down here, how many moles are in 500 grams? So now we're going from grams to moles. You have to make sure you identify first, what are you looking for? It says how many moles, so I'm looking for moles, and then I am given grams. Therefore, I need to go from grams to moles. So the first thing I write down is my given. You're only going to be given one thing. Here you are given 500 grams. Then I set up my picket fence. Now you should see on your pink sheet, diagonal from this, we need to have the molar mass. Well, what's the molar mass? Well, for water, we have to add up the molar masses of 2 hydrogens and 1 oxygen. You end up with 18 grams. And then above that, you'll see on your pink sheet, you just put 1 mole. And that's going to help us solve for moles because we cancel out grams. And all we have left is moles. So what's that going to equal? We have to do 500 multiplied by 1, which is 500, and then divided by 18. So 500 divided by 18. You end up with 27 point, we'll round it up, 27.8 moles of water are in 500 grams of water. So this, you just got to make sure you can identify if we're going from moles to grams or grams to moles, and then you can use your pink sheet. So those are some one-step problems using your pink sheet. 2 more sets of one-step problems, this time going from moles to atoms and atoms to moles. Now, quick clarification. If you see the word molecules or particles, that is the same thing for the test as atoms. You treat it as a problem like this, going from moles to atoms. If you see molecules or particles, treat it like atoms. Please write that down. You can even write it on your pink sheet. Make sure you're treating molecules and particles the same way you treat atoms. For example, right here, it says how many molecules are in 4 moles of water. Therefore, we're going from moles, because we're given moles, to molecules, which is the same as moles to atoms. So we start off with 4.0 moles of water, and then we set up our picket fence. Again, these are just going to be one step. And you will see on your pink sheet, you would put 1.0 mole down here. And then we're going to molecules. How many molecules are in 1 mole? Same as atoms. It's 6.02 times 10 to the 23rd atoms. Or sorry, in this case, molecules. So we cross off moles, and then all we have to do is multiply straight across. Now when you multiply, you got 4.0 multiplied by, and you need to put 6.02 times 10 to the 23rd in parentheses. Every single time, put it in parentheses. Every single time, put it in parentheses. And you end up with 2.4 times 10 to the 24th atoms. Anytime, molecules and atoms, like I said, treat them the same way. Anytime you are solving for atoms, molecules, or particles, you're going to end up with a scientific notation type answer because it's going to be such a big number. So you end up with 2.4 times 10 to the 24th molecules here. Okay, our last dimensional analysis problem, that is one step. How many moles are in 1.95 times 10 to the 24th atoms? That means we are converting from atoms, because we're given atoms, we're converting to moles. So you always write down your given first, which is 1.95 times 10 to the 24th atoms. Then you draw your picket fence, just like that. Draw on the fence. Diagonal from it, you'll see on your pink sheet. You're given everything you need on your pink sheet. You put 6.02 times 10 to the 23rd atoms. And above that, that's how many atoms are in 1 mole. Very straightforward. You cross off atoms, and then all you have to do is 1.95 times 10 to the 24th, 10 to the 24th, and you have to do that divided by 6.02 times 10 to the 23rd, and you end up with 3.24 moles of, well, we weren't dealing with anything specific there, but you would have got the same answer regardless. 3.24 moles in that number of atoms. So that would be your answer. Again, make sure when you are doing this type of division, put it in parentheses. Put this in parentheses. Remind you, put this in parentheses and this in parentheses when you're dividing them, and then you'll be able to get the correct answer. So those are all one-step problems. I'm going to show you 2 examples quickly of 2-step problems, and then we will wrap this thing up. how many atoms in 25 grams of nitrogen? So we're starting off with 25.0 grams. Set up our picket fence. It is going to be 2 steps, so the picket fence needs to be a little longer. First, we are treating this like we're going to moles first. So nitrogen, its molar mass is 14 grams. Above that is 1 mole. Then you need to keep going because you're converting to atoms. So now you just like combine from your pink sheet grams to moles with moles to atoms. So then you would put 1 mole down here and 6.02 times 10 to the 23rd atoms up there. If you look at your pink sheet, you'll see how those combine from grams to moles and then moles to atoms. You cross off grams, you cross off moles, and then you just multiply and divide. So you do 25 multiplied by 6.02 times 10 to the 23rd. Again, put it in parentheses. And then you just divide that answer by 14, and you end up with 1.07 times 10 to the 24th. So your answer should be 1.07 times 10 to the 24th atoms. Victory. All right. Okay. Now you're going from atoms to grams. Always put your given first, 1.55 times 10 to the 15th, and you're just reversing what you did up here. So it's going to be this, but like in reverse. So you're starting off with atoms. So diagonal from atoms, just like on your pink sheet, you put 6.02 times 10 to the 23rd atoms. And then 1 mole above that, because that's equal to 1 mole. And then down here, you would put 1 mole to cancel out that mole, because now you're going from moles to grams. And then nitrogen is 14.0 grams. Oh, man. My bad. Go back. Okay, 14.0 grams right there, and that's awesome because that allows us to cancel out atoms right here. Atoms, cancel out moles, and then you just simply multiply and divide, and you get your answer. So you do 1.55 times 10 to the 15th in parentheses, multiply that by 14, and then divide that in parentheses by 6.02 times 10 to the 23rd, and you end up with 3.6 times 10 to the negative 8th grams. So not that many grams. You end up with 3.6 times 10 to the negative 8th. So you have less than 1 gram in that many atoms. So that's a 2-step problem, a couple 2-step problems. I have more practice with those. If you would like more practice with those, ask me and I can get you more practice with those 2-step problems, but we need to wrap this thing up. So last 2 slides very quickly. Moles in general, just as a reminder, a mole can be represented in one of 2 ways when referring to an element or compound. It can be represented by its molar mass, like 14 grams of nitrogen is 1 mole. So if I said I had 14 grams of nitrogen, you would know I had 1 mole because that's its molar mass. I could say I had 18 grams of water, and that would be 1 mole. So that's how that works. Molar mass equals 1 mole. It can also be represented by its atoms or molecules. The number that always represents a mole is 6.02 times 10 to the 23rd. So if I had 6.02 times 10 to the 23rd molecules of water, its mass would be 18 grams. If I had 6.02 times 10 to the 23rd atoms of nitrogen, its mass would be 14 grams. This right here is equal to 1 mole, and then 1 mole is equal to the molar mass. So if you come across a question that asks you if you have 6.02 times 10 to the 23rd molecules of anything, then all you have to do is calculate its molar mass. And so that's the 2 ways a mole can be represented. And then the last one, percent composition. Remember with percent composition, you first just calculate the molar mass. So for like CO2 would be 44 grams. And then you just separate it into how much of that mass came from carbon and how much came from oxygen. So like in this case, carbon, 12 grams, oxygen 32 grams. And then to solve for the percent composition, you would just do for carbon 12 divided by 44, which gives you 27%. So 27% comes from carbon, and then 32 divided by 44 would give you 73%. So 73% comes from oxygen. And then you can practice on these last 3. The Molar mass of water is 18 grams. I'll do this example for you actually, and then I'll let you practice on the last two. 18 grams, and then from there, 2 grams come from hydrogen, and oxygen. 16 grams come from the oxygen, and so you just do 16 over 18, 16 over 18, and 88%, or about 89%, comes from the oxygen, and about 11% comes from the hydrogen. So that is how we go through percent composition. You just calculate the molar mass first, and then calculate how much of each one of these masses comes from, or how much each element's mass contributes to that overall molar mass, and then just divide and then multiply by 100. If you want more practice with percent composition, go back and watch the percent composition video, and I'll do some more examples. You can practice on these two, and then check your answers. So NO3, KOH, go ahead and practice those, and then here in just a second, I will show the answers to those. So go ahead and practice those right now. First one, NO3, the total molar mass is 62 grams. 62 grams. And about 23% of that comes from nitrogen, and therefore about 77% of that comes from oxygen. If you're getting the wrong answers, then let me know. The total molar mass of KOH is 56 grams. About 70% of that comes from the potassium. Just doing this real quick. And about 29% of that comes from the oxygen, and about 1% comes from the hydrogen. So check your work on that. See how you did. That's my last slide, Unit 5 review. I know it's another long video, but that's because it's a review video, and we're going over so many topics. Tomorrow, good luck on the test. I'm sure you all do well. Farewell.